Thank you. Good afternoon, good evening, everyone. I think we're still in between the afternoon and the evening starting, right? So I'm just going to wish you both ways. First of all, thanks for finding time to be in this session. I know you have a lot of other choices, and you chose this one, so a hearty thank you to all of you. Now, how's this team having a good Hadoop Summit? Yes? No? Come on. You can do better. Are we guys having a good Hadoop Summit so far? Awesome. That's more like it. Great. So what are we talking about? A very mundane topic, of course. Only people who are really, really deep into the space are interested about this. But I'm surprised they accepted my paper and a proposal to present this topic over here. So we're going to talk about securing your big data environments in the cloud. I'm Nishan Tucker. I'm a technical product manager with Microsoft. I look after all of our big data assets, specifically the HD Insight service and all the Azure Data Lake group of products as well. Now, of course, during this session, I'm going to talk about cloud in general, but I'll take the example of Microsoft's Azure platform because that's what I'm more familiar with. You can extrapolate that to the other clouds, and if you have any specific questions I may be able to answer, you can throw them at me as well, right? Now, first of all, how many of us are actually working with a Hadoop or Spark or any kind of big data environment and are hands-on with it today? That's a great thing. Awesome. Now, out of this entire lot, how many of us are working with these environments in the cloud? Wow, that's more than I expected, actually, and that's really promising to know. So we're going to talk security, but from the perspective of cloud deployments, all right? So this is not a deep dive talk on Ranger or Knox or any of those kind of tools over here. If that is what you're here to hear about, you might as well save yourself some time and find a different topic for yourselves. But we will talk about security and securing your big data environments in the cloud, not particularly from the perspective of a particular tool or a service, but more from the cloud perspective in general, all right? So first of all, let's just set the stage over here. Why are we here? What are we talking about? Well, earlier this year, this was one of the articles that came out. Like, I'm sure all of us read some form of it or the other. MongoDB got the short stick, so to call it. But essentially, there were other kind of threats as well, specifically one around HDFS in general, where we had port number 50,070 opened up, and malicious users got access to a lot of Hadoop clusters. And in one case, they even went and purged all of the data and left a message over there stating things that I cannot call out at a public conference. So you can very well understand. And it is estimated that there are about 10,000 HDFS installations in the world which are still vulnerable to such attacks, and you can actually gain access to a lot of that coming forward. Now, before we go any further on the security paradigm, I actually want to set the stage on why is it such a different thing for the cloud? Why are we talking about cloud being something separate over here from a security perspective? And what is actually changing over there? So to kind of set some context over here, here is a traditional Hadoop cluster. And when I say Hadoop cluster, I essentially mean a cluster. It could be a Spark cluster also, right? Now you have a client. Client connects to a master node. Master nodes have access to data nodes. You have the task tracker in there, and then, of course, the job trackers as part of the worker nodes as well. What is important to note as part of the traditional clusters is this small piece over here. when I look at these small layers, this is what is really, really interesting to understand. All of the HDFS pieces as part of a cluster actually form part of the worker nodes itself. The traditional clusters use the storage of the worker nodes and combine them together to form your HDFS. That's the core principle. Anybody has any objections to this? Great. Now, when I look at a Hadoop cluster in the cloud, it's kind of different. There are two ways of doing it. One is you just pick up, lift and shift your on-prem clusters and take it to the cloud and call it a cloud cluster, right? Like you just bring in your worker nodes and head nodes, and you deploy the same infrastructure in the cloud and say, OK, this is my cloud cluster. But in essence, that's a very crude way of doing that. That's like essentially not taking all the advantages that the cloud offers in terms of flexibility, agility, and elasticity as a whole. So what each of the clouds actually recommends is that you implement your cluster in this particular manner. You go ahead and have a compute layer, and you have a storage layer. And both of these do not exist as part of a single cluster, because the agility that you need for your compute environments to be spun up and spun down at will cannot be obtained if you maintain your HDFS as part of your compute clusters itself. Because the moment you purge the clusters, your HDFS is gone if you don't persist it separately. And that's the reason why you persist a HDFS separately inside of either a blob store or an awesomely specialized store like the Azure Data Lake store, right? Now, what does this do? Like, what does decoupling the compute from storage actually mean? I'm sure you guys have all of these questions in your mind. I'm just going to take that off the table right away. Latency, bandwidth, consistency, well, we've thought about it. It's not that we are naive towards those kind of questions. And we've architected these clusters in the cloud as part of the PaaS managed cluster offerings, keeping in mind that we offer you the best of both worlds in that space. In fact, there are other benefits as well. Like if you look at any kind of workload, you reap a lot of benefits from decoupling your compute from the storage environments per se. Now, this is not just all. As part of a cloud deployment, you also have cluster optimization options. Now, if you are in the on-prem world, you'd say, what's so special about this? Well, there's nothing very special about this, but there's something very different about it. As part of a cluster creation cycle, you see that you're able to customize the cluster over here itself, right? Now, after you've deployed this cluster, the better way for you to customize a cluster would be to drop the cluster and recreate it with whatever customizations you need. You don't have that agility in the on-prem world. That's why you cannot do that. But in the cloud world, you can purge your compute layer whenever you want it and bring it up again because your metadata is maintained, your core data is maintained as a persistent store over there. So in essence, the message here is you do not deploy a cluster and then look to plug new services or new capabilities as part of it. You deploy a cluster with all of those capabilities pre-existing, and that's what these PaaS services actually offer as well. Now, I'm sure all of you are already thinking, well, I understand the cloud, and this is an optimized model for it as well, but we're here to learn about security. Help me learn about that. So what's the first step? As part of the cloud model, we saw that we separated compute and storage. In essence, you're not really separating it to be remote. You're keeping it close together, but you're just making sure that your storage is not part of your compute layer, okay? Now, what that means is you need to secure both of these environments specially, right? So the first step that we're going to see is how do you go ahead and secure your data or your HDFS layer. Now, in Azure's case, the best HDFS layer that you have on offer is the Azure Data Lake. It has a very robust security model associated to it as well, and we're going to go through that. Now, the first principle that I want to land over here is all of this is integrated very well with Active Directory, specifically Azure Active Directory, which is Microsoft's way of putting the on-prem Active Directory on the Azure cloud as well. Now, I don't know many enterprises around the world who do not have an Active Directory. I mean, if you know some, let me know, but a recent survey by an analyst actually put it at 99.7% of organizations in the world doing serious business have an Active Directory deployment. So just imagine you being able to port their existing Active Directory directly onto the cloud and being able to leverage the identity mechanisms in there. And that's the reason why the bet on Active Directory as the identity mechanism for everything. Now, what you see over here is a schematic diagram of how the security flows for the data layer in the cloud. Essentially, there is a user. This user has an identity. They have some presence inside of the enterprise Azure Active Directory. When a user wants to log in, the user already has an OAuth token from the Active Directory logged in. Now the user, with the OAuth token, is trying to access your data assets residing in the HDFS layer, right? Now in the cloud, you just don't go ahead and access a server by their IP. You are actually going to access a particular URL, right? Now that URL is protected by an IP firewall that sits on top of this. Now, this is again optional, so it is highly recommended, but from the perspective of the HDFS security pieces, you are free to go ahead and say, I don't need it. But if you need it, you specifically get in and go ahead and configure certain firewall rules determining who gets access to the underlying data assets as it comes across. Now, once you've been able to go ahead and do that, and mind you, this IP firewall is a way for you to restrict your data layer from having a public internet kind of access. Essentially, you're restricting everybody but a few people or a few service principals to come in and access this, right? Now, once you get through that IP firewall and we've been able to determine that you are a legitimate user and you penetrate into the data layer, there is the first level of authentication that happens. As part of the data lake service, now we go ahead and talk back to the Active Directory via graph APIs to determine and ascertain your identity, as well as get security group information around what kind of assets you have access to. Now, this is another very crucial demarcation. Generally, HDFS gives you access at a very broad level. But as part of the security phenomenon as on the cloud, we've been able to define very granular file and folder level ACLs. So essentially, you're getting security information on a very specific basis as to what are the entities that you have access to, right? Now, that is important because that is what is going to govern the authorization phase as part of the steps. Now, in the authorization phase, we compare the security information that we have as part of the OAuth token. Remember, this is still OAuth. I'm sure all of you understand that we will get to the compute layers and talk about the other mechanisms. But here, we are still on OAuth, and we are doing authorizations on the basis of this. Now, once we've determined that this particular user has access or belongs to a security group that has access to the resources he or she is requesting, we then get into the third layer of data protection. As part of data protection, since this is not an on-prem environment sitting inside of the boundaries of your enterprise, and this is a public cloud, that's Azure that we are talking about, we make sure that all the data at all times is absolutely encrypted, right? Now, encryption means that there are keys. As part of the cloud HDFS, or the data lake specifically, we allow the users to maintain those keys, or we allow the service to maintain those keys as well. Either ways, the keys reside in a store called the Azure Key Vault. Neither us or the engineering teams or any other entity has access to the Azure Key Vault unless they are authenticated into it, right? Now, this data protection is turned on automatically in terms of your encryption. But we allow you to turn that encryption off on very rare cases. And there is an option for you to go do that, but before you do that, we definitely want you to be doubly or 100 times sure that you actually want to do that. Because this data is sitting outside of your environment, and we do not want you to assume that somebody else can meddle with your data at all, right? But if you feel that it is degrading the performance of your big data environments because of the encryption, and you've tested it and determined that this is what is actually the bottleneck, then we give you the option to turn that off, but we highly recommend you never do that. The fourth piece then is, after you've gone ahead and achieved the keys and now you're into the store, you're then able to access the data. But every single activity that you do with the data is actually logged for auditing purposes as well. And in fact, we've actually put out some really, really interesting kind of scripts on how you can go ahead and do some intrusion detection as part of those audit logs as well. So you can generate reports and even go ahead and determine what's happening. Now, this is from the storage perspective. Now, just imagine if you were in an on-prem environment, you would actually start with potentially Ranger, isn't it, to define all of these policies. But inside of the cloud, you actually don't even need a cluster at this stage, because you can define all of these as part of the properties of the storage layer itself, your object store or the data lake store that we're talking about over here, right? Now comes the compute pieces over here. As we get into the compute pieces, it's kind of similar from the start, because the user is still getting the OAuth token. But now, the cloud has multiple ways for you to perform analytics on top of the storage environment. The first of which is some of your native analytics capabilities. In Azure's case, that becomes Azure Data Lake Analytics, which is another serverless big data component where you don't have to worry about clusters, etc. Now, Data Lake Analytics, or some of the other analytics components, are actually OAuth compliant. So they get a user. Now, they have to make a decision whether they represent the user back to the store, or they represent the service as a principal identity back to the store to go ahead and muddle with all of the information that's kind of possessed by the stores, right? Now, as you get there, in this case, and in most cases, if the analytics layers are OAuth compliant, they just pass on the OAuth ticket, and the OAuth compliance or the OAuth authentication and authorization pieces continues thereafter. But what happens when you get into an environment where you are with Hadoop and Spark, because these systems are not OAuth compliant? So now, a user sent an OAuth ticket to, let's say, the HD Insight cluster with a Spark deployment on it, okay? Now, Spark is not OAuth compliant today. Its way of security is Kerberos. So what happens now? Well, this is where we need to do a little bit of magic. In essence, we then spin up something called the Azure Direct Active Directory Domain Services, or ADDS. And essentially, the Hadoop or Spark environments then go ahead and talk to this ADDS environment to get a corresponding curb ticket or a Kerberos ticket to your OAuth token. Now again, the question arises whether this Hadoop or Spark environment now represents itself as a service principal identity, or does it pass the OAuth token of the user to the data lake store? In the current time frame, it's actually representing itself as a service principal identity to go ahead and access the data lake store. So when you go ahead and create the cluster, you can actually go ahead and associate a service principal identity to the underlying store, and that's the identity that gets accessed every time you want to go and kind of hit the store underneath. But in the coming weeks or potentially a few months, we should be able to bring in the OAuth token of the user back to the data lake store as well. And this is irrespective. Like, each and every cloud today essentially offers pretty much every true blue deployment available. So Azure offers Hortonworks and Cloudera and HD Insight, which is its managed service. And every Hadoop cluster is going to do pretty much the same thing over here. So be it a Cloudera cluster, which relies on the data lake store as its underlying HDFS, it is still passing on, and it's making the decision whether it needs to pass the service or the OAuth token of the user or represent itself as a service principal identity over there, right? Now that's from a compute environment perspective. Now this is all great, but what happens to the compute environments? How do we go ahead and secure that? To be able to do that, let's just take the example of a typical big data pipeline. Now I'm just going to go ahead and pull this up right up front. And this is, I've taken the example of a retailer. They're bringing in sales information and telemetry information and feedback for suppliers. They have macroeconomists and data scientists connecting back to all of this data and trying to make some correlations around what the data is and what the relationships between the different services look like, right? Now, initially, they want to go ahead and set up a streaming pipeline. They want to do some stream analytics. So Kafka is the ingestion engine, Spark streaming to do some pre-processing, feeding it into the HDFS layer or the big data stores, data lake store or blob store, and then spinning up other Spark or Hadoop clusters to do data processing, like curating, machine learning, all of that stuff, and then using BI tools to then consume all of this curated and processed data. Very typical ETL come machine learning, deep learning pipeline. And in this case, we've taken the example of a retailer, so we'll talk from the perspective of customers and suppliers, right? Now, what's interesting over here is the foundation of the entire security model. So how do we go ahead and lay the foundation? Because that's very important, right? Like, when you build a house, the first thing that you do is you go ahead and ask an architect to kind of create a blueprint, and then you hire a contractor to come in, and the first thing that that contractor does is lays a very strong foundation around it. Our foundation, in this case, is the Azure Active Directory. That's the identity mechanism that you need. And in this case, it was very evident that, like, this particular customer actually wants us to use their existing on-prem AD environments and leverage the security groups and everything that exists to go ahead and put up their big data environments in a very synchronous manner, all right? Now, how do you go about doing that? Well, here's a very simple block diagram from an Active Directory perspective on how that is going to flow through. Now, in this case, you have three distinct environments. You have the big data environment, the Hadoop or Spark environment. You have your Active Directory. And now you also have a third environment from there. Now, essentially, if you did not have the Active Directory domain controller, you would need to define a connection between your big data environment and your Active Directory directly. Now today, you cannot do that, because if you're doing a cloud deployment and your Active Directory resides on premises, you cannot actually go ahead and connect back to it, first. And second, they talk different protocols, because Active Directory or Azure Active Directory has moved on to OAuth, whereas the big data environments, all of the open source stack services and products are still talking Kerberos today, okay? So that's why we have this third environment over here sitting inside of a VNet for the Active Directory domain services. Now remember, these are two different VNet environments, and you'd ask, why can't we put it into the same environment? Well, you actually can, but this is a more robust architecture, because you may have multiple deployments of big data clusters that can leverage a single Active Directory domain services instance if you have them connected via VNet to VNet peering, rather than putting them inside of the same VNet, et cetera. Okay? Now you'd say, this looks like really strenuous. How do you actually go about doing that? Well, not so much. To implement or configure Active Directory domain services, all you need to do is get to your Active Directory and check an option which says Active Directory domain services or directory domain services to yes, and that's it. It takes some time. In essence, it's replicating your entire Active Directory in a highly available environment for you to be able to leverage curb tickets out of. So it takes a couple of hours or a little more than that, I suppose. But then once you configure it, it's always in sync with your Azure Active Directory. Now the second part that you need as part of the cluster, the deployment, is your ingestion piece, your Kafka cluster. Now the requirement from there was, nobody ever wants their environment, be it their first input or be it their last processed output, to be accessible to the public internet. And they were very, like this particular customer was very, very kind of adamant to the fact that there is no way it should be opened up to the public internet. So in essence, for us to be able to do that, we were forced to go to a two-pronged approach. But that actually leveraged a lot of the security principles of the cloud, and thus we're able to share that here. They went ahead and created an application server. Now think of this application server as a jump host, from where Contoso, in this case the customer's name, was trying to access the clusters. And essentially, they just restricted access to the environment of the Kafka clusters via only the application server. How were they able to do that? They were able to put the Kafka clusters and even the rest of the clusters inside of a virtual network or a VNet. And that VNet was secure in nature because it had network security group rules implemented which would allow access to only a few IP addresses, in this case, just the one application server IP address as part of the network security groups. So now, you don't have it open to the entire internet. It's secured via a VNet, and you've defined literally firewall or stronger than firewall network security group rules to define only a single IP to come in over here. Now the entire infrastructure over there, if you notice carefully, is inside of a VNet, but your storage layer is actually sitting outside of this VNet. Why is that so? Each of these services are PaaS services, but the storage layer already has a firewall rule implemented to it, which you have already restricted to either the service principal identity or the IP addresses of the services accessing the web HDFS layer. So you don't need to keep it inside it. And that's why them not being able to be put inside of the VNet is not a restriction at all for us. And then you'd ask, again, seems slightly complicated. How do you go about writing network security group rules. Well, not so much. Here's an example of network security groups being configured for a particular VNet. Essentially, there are just rules. And I have an example of one of these rules over here which says what IP, what port, what priority, and whether I give it access or not. Now, this is for one of these rules over here. If you notice, the only rule that Contoso as an organization designed was this application server rule. There are a set of other rules that are pre-configured or we recommend you configure. Why is that? Sometimes these PaaS services, and in this case they spun up an HD Insight cluster, they have an SLA associated to it. The way we manage that SLA is by being able to do a heartbeat ping into your services and nodes to determine if they are running or not. For us to be able to do those heartbeat pings, you need to allow those IPs for us to be able to ping your clusters. Now, that does not mean that it opens it up to the public internet. We can configure specific IPs that are going to hit, and just those rules need to be configured over here. Again, you may decide you don't want to do that, and you can go ahead and remove these rules. But then, you're literally signing a waiver that you would not hold Microsoft accountable for the SLA, because we are not able to ping it, we are not able to determine what kind of services are running or not, and we are not able to maintain the SLA or spin them up again or take self-healing action for it. Okay? Now, the second piece is creating the cluster inside a VNet. Again, sounds rocket science, but is it really? In the sense of creation of a cluster, you actually have some additional configurations that you can go ahead and do. And as part of that, one of them is VNet configurations. All that you need to select is one click to additional configurations, one click to VNet configuration or virtual network, and then selecting which virtual network and which subnet does this cluster fall into. And that is all that you need to do for a cluster to get secured inside of the network security group rules of the virtual network that you just defined. The third piece is, now you need to go create a Spark cluster, but that Spark cluster needs to talk to a data lake store or a secure HDFS layer. Now, we talked about this being able to be configured using a service principal identity. How do you go ahead and do that? Well, very simple. When you get to the creation of a Spark cluster, you go ahead and select data sources. These data sources can be selected to the data lake store, which is your secure HDFS layer. And then when you get to that, you can now come in over here and configure your service principal using a key and a password around it. All that it's going to do is associate a service principal identity to your cluster so that your cluster now has an identity to access a very secure and robust web HDFS layer sitting underneath it. Okay? Now, when it gets to that particular service principal identity as well, you actually want to get to the layer of allowing that service principal to access your data lake store. So in this case, I'm just adding that service principal with the right level of POSIX access levels to the underlying data store. Now you have a VNet, clusters defined inside of the VNet. Those clusters have a service principal identity, and the identity is configured to access your data layer or your web HDFS layer sitting outside of it. Isn't that great? Now, the second piece to it is how do you configure multi-user authentication? I want to prevent sensitive information to be visible only to privileged users. Now, how do you go about doing that? Well, you have this application server connecting into the Kafka and Spark clusters. And I have separated this VNet from this VNet, but if you read carefully, they are the same VNet essentially. Just for illustration purposes And for a flow, I have just mentioned them in separate places. Now, when you have this Kafka and Spark clusters, they write into the data lake store in a format like this. You have suppliers, and you have subfolders with one supplier and second supplier. And then you have these suppliers connecting back to your Hadoop or Spark cluster and wanting to access this data. You want to secure that a supplier 1 only gets access to their folder, and a supplier 2 only gets access to their folder. How do you go about doing that? Well, as you get into this, you now need to go ahead and replicate your AD as part of your cluster. Essentially, you need to now Kerberize your cluster. Now, if you go to any of the other deployment or distros, this is a pretty lengthy process. It takes you an hour, hour and a half to go ahead and Kerberize these clusters, and you have a set of steps, specifically 9, and if you do one like a little not so well, you got to go back and redo everything all over again. And you can never get that done at one go. In the HD Insight case, all you need to do to Kerberize a cluster is come in over here, say I need a domain join cluster, and go ahead and provide it with the AD information and the identity for you to spin up an organizational unit or OU into that particular AD. And you go ahead and click on Create, and that's it. Within a span of minutes, your cluster is Kerberized automatically. We do everything at the back end for you, and all of these identities are now synced from a security group perspective to your clusters as well. Now, what's actually happening behind the scenes? This is where all the goodness of the open source world really shines up. We are now mapping all of those AD identities back to Ranger policies. As part of secure clusters in HD Insight, we pre-install Ranger as part of your cluster itself. And now, as part of that cluster, you can go back and configure it to bring in all the goodness of Ranger. Just imagine you have 2 users, Alice and Bob, let's say supplier 1, supplier 2, connecting to the HD Insight clusters. They hit a gateway. The gateway goes ahead and authenticates them via the ADDS, gets a curb token. The curb token is passed on to the head node. The head node passes it on to worker nodes, et cetera, and accesses the underlying data stores. But in addition to that, it can now also go ahead and configure all the various Ranger plugins around it. So now, the head node is able to hit Ranger. Ranger can access the Ranger policies residing in the Ranger DB. The Ranger DB can also talk back to AD or ADDS, and then get back with the right level of access for the user around it. Now, I actually had a demo prepared, but I don't think I have the time to show it to you, but I can at least show you what Ranger looks like inside of the HD Insight environment. It's native open source Ranger existing over there. You can go ahead and define policies for Hive over here to say supplier 1 gets access to a particular path inside of, let's say, your storage blobs, or you can go ahead and define the service principal identity inside of the data lake store to access a particular folder level access. Now, the question comes, why didn't you talk about Knox? You talked about everything from VNet peering to configuring security to bringing in Ranger and defining policies, and you secured my entire cluster, but the buzzword today is Knox. Where's that? Well, who can tell me why, as part of this cluster architecture, I'm not talking about Knox? Much before the open source world had this problem of defining an input point to your clusters, the public cloud world had that problem, because it is a public cloud. It's a multi-tenant environment by nature, and you have multiple clusters defined by multiple customers, and how do you define access for one customer to one cluster? That is where we have already put in a highly available gateway or authentication mechanism up there. Those gateways are serving the purpose that Knox is designed to service even before Knox was created. So as part of the cloud cluster architectures, you don't even need Knox to be coming in over here because the authentication mechanism at the input time is already happening over there, right? And you're being able to authenticate a user even before they get to ranger policies, etc. Just to give you a glimpse of some new things that are coming in, you will see these web cloud HDFS layers now showing up as part of the Ranger plugins itself. So like you go ahead and configure HDFS policies, you will be able to configure WASB and data lake store policies, WASB being Windows Azure storage blobs, etc. And you will be able to configure those policies as part of Ranger as well, in addition to configuring them separately. And this is just a ripoff of what it's going to look like. Well, it's going to replicate everything that exists in Ranger. And here's the file and folder level access controls as well. In conclusion, I guess this kind of summarizes everything over here. So from the perimeter security perspective, you have virtual networks and network security groups, through to multi-user authentication, where we use Active Directory and Kerberos, through to authorizing and auditing, we use Ranger and RBACs for admins and POSIX ACLs on the data plane, that's your web HDFS layer. And then to data encryption, which is you already have the server-side encryption implemented, and the internal communications are all happening via HTTPS or TLS in transit. All the security principles that you need for an enterprise-grade cluster to reside on the cloud are thought through and taken care of. And I hope this session gave you a glimpse of what you can do with respect to security in the cloud and what are the right practices around it. Thank you once again for stopping by. I'll be here another 10 minutes or so answering questions, but I'll have to leave the stage. Thank you so much once again.